Welcome to this video. So in this lesson, we are going to look at mass, moles, molecules, and atoms. So specifically, we're going to look at how to convert the mass to moles, okay? And then how to convert the moles to the molecules, and how to convert the molecules to the atoms, okay? All right, so that's what we're going to do in this video. So to convert mass to moles, we use the formula moles is equals to mass over molar mass. Okay, so the mass you will be given, okay? The moles is what you are trying to find, okay? And then the molar mass, you actually get this from the periodic table, okay? So just go on the periodic table to get your molar mass. And then how do we convert these moles that we get here to the molecules? Okay, so there we are going to use what we call as the Avogadro's constant. Okay, so we're going to say 1 mole is equals to 6.02, okay, 3. Some people write this 6.022. Okay, so let me write 22 times 10 to the power 23 molecules. Okay, so to convert from moles to molecules, we are going to be using this ratio here. And then to convert from the molecules to the atoms, okay, we are going to say 1 molecule, okay, 1 molecule contains the number of atoms that are present in that molecule, okay, number of, just going to write number of atoms present in that molecule. Okay, so for example, if I write 1 molecule of water, 1 molecule of water is just H2O. This is 1 molecule of water. So how many atoms are in this 1 molecule of water? Okay, we're just going to count what we have. We have 2 hydrogen atoms and 1 oxygen. So it means we have 3 atoms. Okay, so that's how this last formula works. Okay, we have 1 molecule, and then in that molecule, how many atoms do we have? So we just count individually the number of atoms that we have. Okay, so that's what we are going to be dealing with. Okay, that's what we are going to be dealing with. And then in some circumstances, we'll be converting, okay, yeah, maybe we are converting the number of atoms, okay, to mass. We'll be using what we call as the atomic mass approach, okay? We're going to be using what we call as the atomic mass approach. So that using that approach, okay, the following formulas are going to be important. You have to know that 1 atomic mass unit, okay, is the same as 1.66, okay, 1 times 10 to the power minus 24 grams. Okay, so 1 atomic mass unit is equivalent to this mass here, which is 1.661 times 10 to the power minus what? 24. Okay, and then also we have to know that 1 atom, okay, we have to know that 1 atom, okay, has a relative atomic mass, okay, of that same element that we are dealing with. Okay, so I'm going to say atomic mass unit of the element being considered, of the element being considered. Okay, so this atomic mass here, it's just the same as the molar mass, guys. Don't get confused. Okay, so what I'm saying here is that 1 atom, okay, has the molar mass equivalent to the molar mass of that same atom. That's what I'm saying here. Okay, so for example, if I go back to the periodic table, where is the periodic table here? So when you look at this carbon, let's do carbon, right? So carbon, 1 atom of carbon, okay, has 12 atomic mass units. That's what that statement is meaning, okay? Or if I get 1 atom of oxygen, then it will have equivalent atomic mass there, which is 15.999. Okay, I'll just write it as 16. atomic mass unit. Okay, that's what the last statement here means, this one here. Okay, so we're going to be using those ratios, those formulas as we solve the following questions. So let's look at the questions. Okay, so the first question, they're saying fill in the blank spaces. Okay, so we have to fill in here, here, here. So we have to find the mass, the moles, the number of atoms. Okay, so here we've just been given the number of what? Molecules. Okay, so we know that from the number of molecules, we can actually calculate the number of moles. Okay, and then again, from the number of molecules, we can calculate the number of what? Atoms. So let's start by first calculating the number of moles. So from that ratio that I gave, I said 1 mole is equals to 6.022 times 10 to the power 23 molecules. Molecules. Okay, so now here we want to find the moles of N2O5. So we have the number of molecules that it has, okay, 2.34 times 10 to the power 11 molecules. So we want to convert these molecules here of N2O5 to the number of moles. So I'm going to write X. So cross multiply, okay, it will be this whole thing multiplied by X, and then is equals to this. So that is the same as X is equals to 2.34 times 10 to the power 11 divided by 6.022 times 10 to the power 23. Okay, so this is what we have here. And then you can just simply punch this onto the calculator. Okay, but if you want this other part here, this one is very simple to deal with. So you only punch this part here onto your calculator. Okay, so let's do that. So I have 2.34 divided by 6.022. Okay, so I get 0.3886. I'll just round it off to 4 decimal places. And then times. So here I have 10 to the power 11, 10 to the power 23. So that is the same as 10 to the power 11 minus 23. Okay, so I get 0.3886 times 10. What is 11 minus 23? So 11 minus 23, I get minus 12. Okay, but we want to represent this number in scientific notation. Okay, so we have to move this decimal place one time to the right like that. So if I move it one time, okay, to the right, it means I have to multiply by 10 to the power how many times I've moved it, right? So this will just be 3.886 times 10 to the power minus 1 because I've moved to the right, okay? Times 10 to the power minus 12. So this one and this one I can combine. I will just get 3.886 times 10 to the power minus what? 13. Okay, so those are the number of moles that I get. Okay, what about the number of atoms? So that one will be very simple because we have the number of molecules. So remember we said if, for example, I had water like this, this is one molecule of water. So it has 3 atoms. Okay, so now here I have N2O5. So this is one molecule of this thing. How many atoms does it have? It has 2 N's, 5 oxygens. So it has 7 atoms. So this is the ratio that we're going to use. I'm going to say one molecule has 7 atoms, okay, of N2O5. So what if I have this number of molecules now? How many atoms am I going to have? Okay, so I have 2.34 times 10 to the power 11. And then here, the number of atoms I don't know. So I'm going to say X. So cross multiply, X is going to be equals to this number multiplied by 7. Okay, that number multiplied by 7. So what do we get? So I'm just going to multiply 2.34 multiplied by 7. I get 16.38 times 10 to the power 11 atoms. Okay, but we want to represent this number in scientific notation. So I'm going to move this decimal point one place to the left. So I have 1.63 0.38 times 10 to the power. So here I moved to the left like that. So I have to multiply by 10 to the power positive number of how many times I've moved to the left. So I just moved once. So I'll multiply by 10 to the power 1. And then I also have this one times 10 to the power 11 atoms. So these ones are the same base. We can add their powers. We get 1.638 times 10 to the power 12 atoms. Okay, so here I can write 1.363 times 10 to the power 12. Okay, so if you don't want to the trouble of moving the decimal point, okay, you can just punch it on the calculator. Okay, just make sure you add brackets to your numbers. That way you are not going to make errors. Okay, so those will be the number of atoms that I have. Okay, so we're just now remaining with the number, the mass, I mean. Okay, we're just remaining with the mass. So how do we get the mass? Okay, the mass, we use the moles, and then we can get the molar mass of this guy from the periodic table. So I have N2O5. So I can say 5 multiplied by the mass of oxygen. Okay, so the mass of oxygen, what's the molar mass of oxygen? Okay, so we can just write 16. And then here, I have 2 multiplied by the molar mass of nitrogen. So nitrogen is here. So nitrogen has 14. So I'm just going to write 14 here. So 5 multiplied by 16. Okay, so this is now grade 12. It's 80. And then 14 multiplied by 2 is 28. So the molar mass of this whole thing will just be 8, 10. So it will be 10, 8 grams per mole. So this will be the molar mass. Okay. Now remember, moles is equals to mass over molar mass, right? So this is my molar mass. And then I also have the moles. So I can find the mass. So cross multiply mass is equals to the moles multiplied by the molar mass. So the molar mass is 108 multiplied by the moles, 3.886 times 10 to the power minus 13. Okay, so let's multiply this now to see what we are going to get. Okay, so when I multiply that, I get what? So 108 multiplied by 3.886, I get 419.688 times 10 to the power minus 3. But this is not scientific form. Okay, so we move this decimal place 2 times to the left. So 1, 2. So that would mean I have 4.19688 times 10 to the power 2, because I've moved the decimal place 2 times to the left. So the power is positive, and then times 10 to the power minus 13. So this is mass. So this is grams. Okay. So I can combine those 10 to the power something. So mass is equals to 4.19. Okay, 19. I can even round it off to 197. Okay. And then times 10 to the power 11 grams. So that would be the mass here. Okay, so mass, grams, this is moles, these are molecules, these are atoms. Okay, so that's how we can find the number of moles, can find the number of atoms, can find the number of molecules and mass. So they can give you anything. So here, in this case, they gave us the number of molecules. Then from the molecules, you saw how we got the atoms, the moles and the mass. Okay, so in another case, they can just give you maybe the mass, and then they tell you to find the rest. So from the mass, you will know how to find the moles. After find the moles, you change them to number of molecules. After you find the number of molecules, you change them to the number of atoms, and then you're done. So that's how you're going to do it. So now let's check what number 5 is and number 6. Okay, so it's actually the same thing. We're just converting from the number of what to the what. But here, okay, we're going to be using specific methods on question 6 and 5. Okay, so question 5, they're saying calculate the mass of uranium that contains 7.16 times 10 to the power 13 atoms of uranium. And then they have given us a specific method to use here. So they've said use the atomic mass unit approach. So if we are using the atomic mass unit approach, then we have to know that one atomic mass unit is actually equals to 1.661 times 10 to the power minus 24 grams. Okay, so we want to calculate the mass. So we're going to use this thing here. So in here, we've been given how many atoms? 1.16 times 10 to the power 13 atoms of uranium. Okay, so now remember from the definition, when we're just starting, I said one atom, okay, one atom has how many atomic mass units? It has the atomic mass units equivalent to the molar mass of that atom, right? So here we're talking about uranium. So what is the molar mass of uranium? So you go on your periodic table here. So where is my uranium? Okay. Uranium, where are you? Uranium. So uranium, I can see it. Okay, so okay. Maybe we go row by row. Okay, so uranium is down here. No wonder I wasn't seeing it. Okay, so uranium should be down here somewhere. Okay, yeah, I've seen it now. So uranium is here. That's my uranium there. Okay, so what is the molar mass of this uranium? We can see it's 238.0289. So if you want, you can round it off, or if you want to just get this same number here. Okay, so that is 238.0289. So I'll just round it off to 03 there. So that is the molar mass. Okay, so I'm going to say one atom of this uranium has, okay, according to the periodic table, 238.03 atomic mass units, if it's just one atom. So what about these atoms here, which are 7.16 times 10 to the power 13? Okay, how many atomic mass units are they going to have? So we cross multiply there. Okay, so it will be x multiplied by 1, that will just give me x is equals to, and then this number multiplied by this. What are we going to get as our atomic mass units for these 7.16 times 10 to the power 13 atoms? So we go on the calculator, we punch. So I have 238.03 multiplied by 7.16, okay? And then multiplied by 10 to the power 13. Okay, so 10 to the power 13. Okay, let me do it again. It has disappeared. Let me calculate. Okay, so I'm saying I have 1.13 times 10, okay, to the power 13. Okay, that's what I have. And then I'm multiplying that by 238.03. Okay, so there I'm going to get 1.704, and then 3 times 10 to the power 16 atomic mass units. Okay, so if one atom of uranium has these atomic mass units, then it means these atoms of uranium are going to have that atomic mass unit. Okay, and then now, since I have the atomic mass units, I can use this relationship to find the mass. Okay, so the mass, we're going to say it's like this one. Okay, so mass, we're going to say one atomic mass unit has the mass 1.661 times 10 to the power minus 24 grams. What about if I have 1.7043 times 10 to the power 16? Okay, what will be my mass? So cross multiply, x will be equals to this number multiplied by this. So I'm going to multiply 1.7043 0.743 multiplied by 1.661 alone, then multiplied by 10 to the power 16 multiplied by 10, okay, multiplied by 10 to the power minus 24, like this. So we can start with what is in the first bracket, 1.703 multiplied by 1.66, okay, 1.661. Okay, so I get 2.8308423 multiplied by, here the bases are the same, so we can just add the powers. Okay, so 16 minus 24. I'm going to get 10 to the power minus 28, and these will be grams. Okay, so it means my mass, okay, so mass just be equals to 2.8. I can round it off to two significant figures times 10 to the power minus 80 grams. Okay, so it means this here will be the mass of 7.16 times 10 to the power 13 atoms of what? Uranium. Okay, so now let's solve question 6. So we are done with question 5. Let's solve question 6. Okay. All right, so question 6, they're saying how many molecules of C2H6 are contained in 4.73 micrograms of this C2H6. And then here they are telling us use the more concept approach. So if you are using the more concept approach, then we know that one more is equals to, okay, it can be one more of anything, to be equals to 6.022 times 10 to the power 23 molecules. Okay, so now here, if we want to find how many molecules of these we have, then it means we have to convert the mass to the moles. So now the mass, notice it has been given in micrograms. So it means, first of all, we have to convert it to what? To grams. So when we are learning how to convert these units, I said just convert using the metric system. So what is the value of the micro on the metric table? Okay, what is the value of the micro on the metric table? Okay, so we said the micro is 10 to the power minus 6. So converting these micrograms to grams would just be 4.73 times 10 to the power minus 6 grams. So we've converted the mass to grams. So now we have to find the moles. Okay, so moles is equals to the mass in grams over the molar mass. So the molar mass we get from the periodic table. Okay, so what we have here is C2H6. Okay, so C2H6. So this will be 6 multiplied by molar mass of hydrogen, and then 2 multiplied by the molar mass of carbon. So for carbon, 12.01 times for the hydrogen is 1.01. Okay, so from there I get 6.06, and then here, what am I going to get? I get 24.02. So when I add this, I get 80, and then there it will be 0, and then 3. Okay, so I get 30.08. So that is my molar mass there, grams per mole. So it means the moles will just be equals to the mass, 4.73 times 10 to the power minus 6 divided by the molar mass, 30.08. This will give me the moles as approximately 1.7. Okay, let me do it again. Okay, so 4.73 times 10 to the power minus 6. Okay, and then I'm dividing this by 30.08. Okay, I get 1.573 times, okay, times 10 to the power minus 7 moles. Okay, so now I have the number of moles. So it means I can use this ratio now. 1 mole is equals to this number of molecules. Okay, because that's what the mole concept says. So let's find the number of molecules now, since we have the moles. Okay, so we're using this ratio here. So I'm going to say 1 mole has 6.022 times 10 to the power 23 molecules. What about if I have 1.7573 times 10 to the power minus 7 moles? How many molecules am I going to have? So you cross multiply there. So X will be equals to, and then here I multiply this multiplied by this. Okay, so I'll multiply 1.573 with the 6.022. Okay, so 1.753 multiplied by 6.022, I get 9.472606 times, and then here I have 10 to the power minus 7 and 10 to the power 23. Okay, so 10 to the power minus 7 multiplied by 10 to the power 23. So here we can just add them. Okay, so what is it? 23 minus 7. I get 16. So this will be 10 to the power 16. Okay, so we can put in three significant figures. This will be 9.47 times 10 to the power 16 molecules. Okay, so that will be our answer there. That will be our answer there. Okay, we're done this. Let's look at the last question, which is question 7. So the moles of copper sulfate hydrate, which has this formula, was found to be 1.25 millimoles. Okay, first question, how many molecules of hydrogen are contained in this hydrate? Okay, so for me to find the number of molecules of hydrogen, okay, I first have to find the number of moles, okay, of molecules of hydrogen. So from this formula here, CuSO4, okay, point, the water of hydration like this, okay. So this whole thing here is considered as one molecule, okay. One molecule of copper sulfate hydrate, okay. And then if we were to get more ratios, okay, if we were to get more ratios of the copper sulfate hydrate, okay, to the molecules of hydrogen, okay, what would be the mole ratio? Okay, so this whole thing here, we're considering it as 1. So the mole ratio will be 1, 2, okay? And then how many molecules, okay? How many moles, okay? How many moles of hydrogen molecules can we see there? Okay, remember a molecule is something like H2 or O2. Okay, so it has to be grouped 2, okay? So you have one atom and then you combine it with another one. Then they form a molecule. So how many molecules of hydrogen can we see here? We can see that this here, okay? Just this part here that I've put in a box here, okay? That's one molecule of hydrogen, okay? And then I'm multiplying it by 5. So it means I have 5, okay? I have 5 of these molecules of hydrogen. So I'm going to say the mole ratio here, okay, of this whole thing, if I consider it as 1 to the number of hydrogen molecules is 1 to 5, okay? So meaning if I have 1 more of this, then I have 5 moles of hydrogen molecules, okay? So now in this case, in this question, we've been given that the moles of this whole thing is 1.25 millimoles. So the best thing here is first to change the millimoles to moles, okay? So we just use the metric system. So what is milli? Okay, what is milli? So we know that milli is 10 to the power minus 3. So if I change this 1.5 millimoles to moles to just be 1.25, times, where those milli here, we replace it with the value from the metric system, and then moles. Okay, so if you are lost here on how we are converting these units, please go back and watch the videos on tutorial sheet 1 or on the videos where we are talking about unit conversions. Okay, right. So these are the moles that we have for this copper hydrate solution, copper sulfate hydrate, I mean. Okay, so if I have one more of this, I have 5 moles of hydrogen molecules. So now what if I have 1.25 times 10 to the power minus 3 moles of this thing? Okay, how many moles of the hydrogen molecules am I going to have? So cross multiply. Okay, 1 multiplied by x, I get x is equals to, and then this multiplied by 5. So what am I going to get? Okay, so it will be 5 multiplied by 1.25. That will be 6.25 times 10 to the power minus 3. And then this here will just be what? Moles. Okay, because this was the mole ratio here. If I have one more of this, then I have 5 moles of hydrogen molecules. So what if I have this number of moles, then I have these moles of hydrogen molecules. So even here I can write hydrogen, okay, molecules. So now from the number of moles of hydrogen of molecules, I can now get the number of what? Molecules, this one. Because here the question was asking us how many molecules of hydrogen are contained there. Okay, so first have to find its moles, and then now we can find the number of molecules. Okay, so we're going to say one mole of anything contains 6.022 times 10 to the power 23 molecules. So what about if I have these moles now? 6.25 times 10 to the power minus 3 moles. How many molecules am I going to have? So cross multiply. Okay, you're going to have x is equals to this multiplied by this. Okay, so 6.25 multiplied by 6.022. So that will be 37.6375 times, and then 10 to the power 3 multiplied by 10 to the power 23, I'll get 10 to the power 20. And these will be molecules of what? Hydrogen. Okay, so we can move this point one step to the left. So we can express it in scientific notation. Okay, so the way it is here, it's not scientific notation, because scientific notation, the number that you have here should be more than 1, but greater. It should be more than 1, but less than 10. So this 37, it's way beyond 10, so it's not scientific notation. So I bring this one over there, so it will be 3.76375 times 10. So I've moved to the left one time. So I'm going to put power 1 multiplied by 10 to the power 21, and then 20, and then molecules. Okay, so we can add those, or we can combine the 10s to the power something. So what are we going to get there? We're going to get x is equals to 3.7. Okay, I can round it off to 3 significant figures. 6 times 10 to the power 21 molecules of hydrogen. Okay, so that's how we find the answer there. So we have 3.7 molecules of hydrogen. Okay, and then from there, what can we do? We can try to find B. Okay, so what are they saying on B? So B, okay, B, oh, let me keep this value here somewhere in case we want to use it. Let me just write it at the top here. So 3.76 times 10 to the power 21 molecules. Okay, and then now what about B? So B, they're saying what mass of water would be released during the dehydration process. So if I write this formula, Okay, and then I get the mole ratio of this whole thing to water. What do I have? The mole ratio again would just be 1 to 5. Okay, meaning 1 mole of this will have 5 moles of water. So you can see it from here. So this here is just 1 mole of water. So multiplied by 5, I have 5 moles of water. So in 1 mole, okay, in 1 mole of this whole thing here, I see 5 moles of water. So my mole ratio is 1 mole of this contains 5 mole of water. So what about if I have these moles now, which I said was just 1.25 times 10 to the power minus 3 moles? How many moles of water am I going to have? And then once I have the moles of water, okay, I can now find my mass of water, because I know my molar mass of water is very simple to find. Okay, so cross multiply, I have x is equals to, this here will just be what? We already found such an answer there. So we found it was 6.25 times 10 to the power minus 3. And then these are moles. Okay, so these are moles of water now. We are not considering hydrogen. Okay, moles of water. And then once we have the moles of water, we know the molar mass. So molar mass of water, okay, it's how much? Okay, so water is H2O. Or I should write it here. So water is H2O. So 2 multiplied by the molar mass of hydrogen, okay, plus the molar mass of oxygen. Okay, so that will give me 18.02 grams per mole. So I have the molar mass and I have the moles. So I can find the mass now. So mass will just be equals to molar mass multiplied by the moles. So the molar mass is 18.02 multiplied by the molar mass, the moles, 6.25 times 10 to the power minus 3. So I'll just put this directly into the calculator, the all of it. So it will be 18.02 multiplied by 6.25 multiplied by 10 to the power minus 3. Okay, so what do I get there as my moles of water? As my mass, I get 112.626 grams. Okay, so that's what I get there as my, okay, am I correct? Okay, no, I didn't do the calculations correctly on the calculator. Let me redo them. Okay, so I have 18.02, okay, multiplied by 6.25 times 10 to the power minus 3. Okay, to the power minus 3. Okay, now I get the correct answer. So the correct answer is that the mass should be 0.112625 grams. Okay, so that would be the mass of the water. Okay, so any questions? All right, so if there are no questions, then we are done with this tutorial sheet. So we are solving tutorial sheet 2. Where is it? Okay, we are solving tutorial sheet 2, which is this one. So we solved question 1, 2, 3, 4, 5, 6, and 7. Okay, so we are done with that. Thank you so much for watching. And if you'd like to register for our online classes, okay, you are free to register with us. You can inbox me on the number in the description. Okay, so have a blessed day.